Thank you so much for joining. In this chapter, we will cover some basic 802.11 IEEE standards. Okay, so just like wired is denoted by 802.3, wireless is denoted by 802.11. Anything beyond this, 802.11a or b or g or h or k or r, anything, it means we are all talking about the Wi-Fi standards. This is all a part of Wi-Fi and a lot more standards as well. We're going to cover those in this video and the next video. So when we say 802.11, we are of course talking about Wi-Fi, but we are talking about from a time where in the year 1997 when the standard was kind of the standard came to light, and we call 802.11 as the legacy standard because after that we also came across a few new standards: 802.11b, 802.11g, 802.11a, so on and so forth. Okay, so we'll cover and we'll discuss about these standards one by one. It's going to be interesting because now is when we are actually starting the real Wi-Fi discussions and discussing about the different standards there are in the Wi-Fi world. Okay, so we understood that whenever some bits need to be sent onto the signal, we need to do some modulation, encoding on the signal, and then it becomes a carrier signal, right? 802.11 is called legacy, and the RF technology used behind this is called DSSS, direct sequence spread spectrum. This means this is how the bits are encoded onto the signal to make it a carrier signal. 802.11 supports 1 and 2 Mbps of data rates, just 1 and 2. Okay, 1 and 2 Mbps of data rates. Now, this is from a time when we already had fast Ethernet ports, or we were on the wired side, and we were now about to get 1 and 2 Mbps of traffic on the Wi-Fi, which was good enough, but we always want more, right? So when 1 and 2 Mbps came into the picture, we wanted to go beyond this. We wanted to, of course, get some more data, and hence we developed, or we founded, a standard called 802.11b, which works on 2.4 gigahertz, and this uses the RF technology of HRDSSS, which means high rate DSSS. Now with 802.11b, we could support the data rates of up to 1.12, 5.5, and 11 Mbps. Okay, with better modulation, we were able to achieve higher data rates, right? And this is strictly in 2.4 gigahertz band. And we also need to know that with in 2.4 gigahertz band, we have other devices also working like Bluetooth. We have baby monitors. We have microwaves, etc., which usually raises the noise floor of the 2.4 gigahertz spectrum. Hence, it's always crowded. Okay. Moving forward, we got up to 11 Mbps, but we were not convinced. We wanted a lot more, and that's the reason why we came up with a standard of 802.11a, which works on 5 gigahertz spectrum. We got a new frequency, 5 gigahertz, which we were allowed to pass traffic. Now, this standard uses the RF technology of OFDM, that is orthogonal frequency division multiplexing. Now, with this new technology, with this better modulation, we were able to receive or support data rates up to 54 Mbps, 6, 9, 12, 18, 24, 36, 48, and 54 Mbps, right? Again, it's a newer frequency, it's a 5 gigahertz frequency, but in the old days, we had a lot of devices which were built to only support 2.4 and 5 was just coming up. So we had a lot of old devices which only supported 2.4 and hence they were restricted to 11 Mbps only. They could not support 54 because the newer models which were coming out now, the newer laptops, they had a 5 gigahertz chip in it, and that was very rare. Okay, so it was very, very fortunate folks who were getting a chance to work on 5 gigahertz during that time. We're talking about early 2000s. So what happened after that was we also wanted to make sure that yes, we should be able to achieve higher throughput or higher data rates in 2.4 gigahertz spectrum also. And hence we got a standard 802.11g, which is a 2.4 gigahertz spectrum, but the RF technology used behind that is ERP, Extended Rate Physical. ERP OFDM became mandatory along with ERP DSSS, kind of like a combination of A and B, dot 11A and dot 11B. Okay. Now with this better modulation in 2.4, we were able to support data rates of dot 11B and dot 11A combined. Hence, we support 1, 2, 5.5, 6, 11, 12, 18, 24, 36, 48, and 54 Mbps. Okay. Now, this is how on 2.4 also we are able to go as long as far as 54 Mbps, right? This is some basic information about these standards. In this chapter, we are not going to go in details about a lot of things about these standards. We will cover those in the following chapters, but there are certain things which you should know, which I will discuss in this chapter as well. So dot 11 is the legacy standard which supports 1 and 2 Mbps. Dot 11b is 2.4 gigahertz, supports HRDSS and takes care of up to 11 Mbps of data rate. Of course, it is very crowded because there are other devices also working in that spectrum, which is going to cause a lot of interference, and hence it's not easy to send traffic in that particular spectrum. Now, because of which a new spectrum was actually discovered or was actually allowed to us by the government. That's the 5 gigahertz spectrum, which uses OFDM RF technology or OFDM modulation, which supports up to 54 Mbps of data rate. Dot 11G, the next standard which works on 2.4 gigahertz spectrum, supports ERP, that is Extended Rate Physical, OFDM and DSSS, which is a combination of 802.11a and 802.11b, and hence the data rates are also combined 1, 2, 5.5, 6, 11, 12, 18, up to all the way up to 54 Mbps. Okay, now in 802.11b, or let's say 2.4 gigahertz frequency, we have an unlicensed band which we get. In 5 gigahertz, we get unlicensed band, of course. The 2.4 gigahertz band has approximately 72 megahertz of frequency width to send traffic. I will go in details in the following chapter. I'll draw each channel on the screen for you to understand better. But just understand that for now, in 2.4 gigahertz, we get up to 72 megahertz of channel of bandwidth to send traffic, as compared to approximately 555 megahertz of trap of bandwidth in 5 gigahertz, which is way higher than what we get in 2.4. Plus, we have the other stuff like baby monitors, microwave, Bluetooth devices also running on 2.4, which makes it really difficult for us to send traffic without any problem in 2.4, and hence people move to 5 gigahertz now. Okay, we're going to go in details in the channels very soon, but for now, just this is enough. So 2.4 and 5, a huge gap in the frequency range and a huge gap in what we get to send traffic, right? Okay, so now what we can do is we can, of course, go ahead and understand some things more about 802.11b, 802.11a, 802.11g. This is 2.4 gigahertz, supports HRDSSS. This kind of table will be handy for you. This is 5 gigahertz. It supports OFDM. Dot 11G is again on 2.4 gigahertz only, not on 5. Supports ERP OFDM and ERP DSSS. Before that, there was something called Legacy, which was also on 2.4 gigahertz, supported only DSSS. Now this supports maximum data rate is 11 Mbps, maximum data rate is 54 Mbps, maximum data rate is again 54 Mbps, maximum data rate here is 2 Mbps. So this is how the evolution happened. Okay. Of course, we also got some other standards like 802.11n, 802.11ac, and now we also have 802.11ax. Before we go in detail about these three standards, I'm anyway going to create a different video for these standards for all of you to get and to get the understanding of these three very important standards in the Wi-Fi world. But we also have some other standards like 802.11i, 802.11k, 802.11r, w, and so on and so forth. We will uncover these in the following video. Okay. Thank you so much.